Hello guys, welcome to the channel. Today we will discuss regularization techniques in linear models. Okay. So first, what is regularization? Regularization is a technique used to reduce overfitting in machine learning models. What is overfitting? Overfitting means modern learned noise plus patterns perform poorly on new data. What it means? Always remember, a good model learns only the real pattern. An overfitted model learns everything, including noisy data also. So we just need to train the model on the real pattern. Okay, not on noisy data, means everything. And overfitting means suppose I have a data set and of how many hours you study and how much marks you get. Suppose I have data set. Someone studies for 1 hour and he got 40 marks. Someone studied for 2 hours, got 50 marks. And one value came. Someone studied 1.1 hours and he got 95 marks. So that is right data. But in our case, that is an case of overfitting. We can't train our model on that particular data. So this is what overfitting and what regularization do adds a penalty to the model to keep it simple. Simple. It will add a penalty to the features so that our model will be simple and will be only gets trained on basically the real patterns, not noisy data. Okay. So why regularization is needed? Model becomes too complex. Okay. Suppose you have a case of overfitting and underfitting both in your data set. Some not necessary features or columns in your data set. Okay. Coefficients become very large. Model model memorize instead of learning. But every model should learn, not memorize the data, right? So so how we can perform regularization? We have two methods. Okay, for linear model. Okay, for linear model. First, L1 regularization means lasso regression. Okay, it adds absolute values of coefficient and can make some coefficients exactly zero. What it means? Suppose I have this data set. Okay, and this is my output column. Okay, on the basis of this till H column, these are my input column. On the basis of this input column, this output column is changing, right? So, suppose I have this data set. Okay, I have this column. Okay, and it is not adding any like major changes to my this output column. Or this is in simple words. See, suppose this column is not necessary for me. Okay, it is just increasing the complexity of my model or of my data. Okay. So what lasso regression do? It will make all the coefficients equal to zero. It will make this column as zero. Okay. So so basically by this method, model automatically does feature selection. And what is feature selection? How to do feature selection? I have already discussed. You can check my video. Okay. Okay. It basically removes unnecessary features. What this method actually do? Removes basically unnecessary features. Like suppose this is my unnecessary feature, it will remove them. Okay. So this method we understood what it do, when to use when you have many features, okay, and when you want to remove useless features, right? Now, second, L2 regularization, ridge regression, okay, it adds a square of coefficients, strings value, but never makes them zero. it makes the coefficient zero, but it never makes the coefficient zero. Remember that. Okay. It adds square of coefficient. What it means? Keep all features but reduces their impact. When to use? When all features are important, means all the columns of your data is important. You have to take all the data, then you can apply this method. And okay, suppose suppose this is my data. Okay, this is my column, input column. Okay, so you can see weight of this column is too much. Okay, too much weight of this column. When we will apply this method ridge regression, it will reduce the weight of this input column. It will not make them zero because this is the necessary column for me. Okay, so it will reduce the weight of the column. Okay, now we will see how we can do it practically. Okay, so first I will copy my file location. I will search Anaconda prompt. cd, okay, enter, write Jupyter Lab. It will open the Jupyter Lab into my browser. I will wait for few seconds. Now I will choose this. I will rename this regularization techniques. Okay. Now, first I will import some required libraries. Import numpy as np. Import pandas as pd. We are not importing matplotlib and sequence because I have not to uh, basically I have not to draw a graph, so I will not import that. Now I will load my data set. Data is equal to pd.read slash csv because I have csv file. For every video, I'm giving the data set. So this is my data set. Right click, copy path, control D. Now I will check my data is loaded or not by checking first three rows. Yeah, my data gets loaded and these are my first three rows. Now, first I will check is there any null value before performing any operation on it. Yeah, I have 207 null values in total bedrooms column, right? So I will fill that first data dot fill and sorry, I have to fill this dot fill and suppose I will fill by the total bedrooms median. Okay, how we can do that? I will again take dot fill total bedrooms null value dot fill and by its median. Okay, in place equal to true. Okay, this is an warning. This is not an error. Okay, now suppose I will I will draw a heat map. Okay, I will plot a heat map. Okay, put matplotlib dot pyplot as plt import cborn as sms. Now I will show you by plotting a heat map to show you how my features are affecting my output column or not. Heat map. I will take data as my data's correlation, not is equal to true. PHP dot show. Now see longitude minus 0.046. So that is not affecting my data, right? So this is a useless feature for me. Latitude also same. House, median, age. This is affecting my output column a little bit. This is also affecting my output column a little bit. It is 0.049, I think. So this is also not that much useful for me. This feature population 0.025 minus 0.025. So it is a useless column for me. Households again, that is not a good feature for me. And median income, yeah, this is 0.61. Yeah, this is an important column for me because it is nearly 1. Okay, so now I will first divide my data set into two parts, input and output. This is my input column and these are my this is my output column and these are my input columns, right? I will take all the input columns into my X. Suppose data dot drop. I will drop this only output column. I will enter. I will write x is equal to 1 and y is equal to data. I will take the output column. Sorry, it is already copied. Okay. So I have divided my data set into input and output. Now I will do basically feature scaling by standardization. I have already discussed in detail how to perform feature scaling using standardization. You can check the video. Okay, first from scalar dot model selection import standard scalar. Okay, scalar. Okay, okay. For that, processing. Okay, now now suppose I will create an object for calling standard scalar. Okay, Now I have to fit my standard scalar for my x because all the input values are my x. So I will fit my x to a standard scalar. Okay, it gets fitted. Now, now I will import this into a data frame. See the transform x columns is equal to x x dot columns, right? Now, now I will divide my data set into training data and testing data. Now suppose I will divide my data set into 80% for training data and 20% for testing data. I will all these things train test split standard scaling all these things I've already discussed. You can check my previous videos. Okay, I will check. I will give all the four variable y train y test is equal to I will sorry, first have to I will have to import train test split from sklearn dot model selection import train test split. Now I will call my train test split. I've taken x and y variables. So I will give that. Now test size means how much we need testing data 20%. So I will write test size equal to 0.2 and I will give random state is equal to 42. Okay. Now my data gets divided into training data and testing data also. Okay. Now, now I will first make a model. Then I will apply these two methods, ridge regression and lasso regression. Okay. So first I will import scalar dot linear model. Import first I will import linear regression, lasso and ridge. Okay. I will import all this. Okay. Now first I will make a make an object to call my linear regression. Okay. Now now I will train my model. How I can train lr dot fit my training data. By training data, I will train the model. So it gets fitted. Now I will check my lr dot score. Okay. Y test into 100. So yeah, this model is giving accuracy of 61, which is very low accuracy, right? So this means we need to apply these methods, okay, for controlling our model to remove basically uh, not unnecessary columns, or we need to remove the weights of the columns, right? Suppose I will give the matlab, uh, I mean, I will check the coefficient means uh, it will give the weight of each feature in the model. Each feature means each column in the model. Okay, it will give the weights of each feature in the model. So yeah, it gave me it gave me the weights of each feature. Okay, so this is how you can see the weights of each column of my input column, right? So now I will show you. First, we will calculate how wrong is my model. Means mean absolute error, uh, mean squared error. Okay. So first, I have to import from sklearn dot metrics import mean absolute error and mean squared error. Okay. I have imported this. Now, first, I will calculate mean squared error. Means how much is the difference between my predicted value and the actual value. And I will do means mean squared error. Means square that value. Give basically suppose I got 2, then just square 2 means I will get 4. Okay. So mean squared error, just the difference between my actual value and the predicted value. Okay, mean squared error. Sorry, y test L, and I will take lr dot predict x test, right? I will see my MSC. So yeah, I got my mean squared error. It is too much high. Now, now I will calculate mean absolute error. Okay, average of absolute errors. Okay, average of absolute errors. Let's take MA is equal to mean absolute error. Same I will with this. Now I will see my MA. So yeah, I got my mean absolute error. Mean average of absolute errors. Okay. Now I will calculate RMSC is equal to first I will have to import numpy. Yeah, I have already imported numpy. Okay. RMSC is equal to NP dot square root means our actual error. Okay. Actual errors mean. Okay. Means we have squared for MSC the mean of the squared error. I have squared the error, right? Basically the difference between my predicted value and the actual value. I received that for whole columns, and then I received my mean, and then I squared this. Okay, now I will calculate its actual error mean. Okay, actual error mean. So actual error mean is this. Okay, without doing a square of this. Okay, now Now we will see how to apply these regularization methods for my linear model. Okay. Now first is my lasso regression, right? I will first see lasso regression first. LA, let's take LA, call lasso alpha is equal to 0.5. What is alpha 0.5 means? Means uh, applied moderate penalty to the coefficients. Okay, coefficients mean the values of my feature. Okay, moderate means not too much low, not too much high. Apply the penalty for my coefficient for the feature. Okay, moderate penalty I'm applying. Okay, now now I will just do LA dot fit. What I will fit X train and Y train, right? Okay, yeah, it gets fitted. Okay, so we saw how to use lasso, right? And now we will see ridge regression. Only difference is alpha we have to choose. Okay, in this suppose I have to do strong regularization. Okay, so I will choose alpha is equal to let's say 10. Okay, sorry, again I will suppose take Ri and here I will write ridge. Okay, now I will fit my X train and Y train into ridge. Sorry, Y train. Okay, it gets fitted. So this is how we ap- we perform lasso and ridge for regularization. Okay, so that's all in this video. In from the next video, we will see logistic regression. Okay, thank you.